So lesson 3.2 is all about solving a system of equations algebraically. The first method we're going to look at for solving systems algebraically is the elimination method. Our first example is 5x minus y equals 16 and 2x plus 3y equals 3. So in the elimination method, what we're looking to do is to eliminate one of our variables. We're looking to either make the x variable or the y variable cancel out. So what we want to do is decide which variable we are going to eliminate. Now, in this problem, the easiest variable that we are going to have to get rid of is the y variable. The reason why is what we want to happen is if we were to combine these two equations together, so we would go up and down the rows, combining like terms together, we want the y's to cancel out. So in order to make the y's, which are like terms, cancel out, what I would have to do is multiply this top equation by a positive 3. When I do that, I'm going to distribute 3 to the entire first equation. So I'd have a new equation, 15x minus 3y equals 48. Now, I'm going to leave the bottom equation alone. And now when I go to combine like terms together, 15x plus 2x is going to give me 17x. Negative 3y plus 3y is going to cancel out and eliminate my y's, which was what I was hoping to do. And then 48 plus 3 is equal to 51. So now I can solve this equation, divide both sides by 17, and I'm going to get x is equal to 3. So I was able to eliminate my y variable in both equations and get a solution for x. So now if I want to go back and find what y is equal to, I can pick from either one of my equations, the originals in purple, and I'm going to substitute x equals 3 in. So it doesn't matter which equation you choose, I'm just going to go with the first equation. So I'm taking my original first equation, instead of an x, I'm going to replace it with 3. And now I'm just going to solve this equation to try and find out what y is equal to. I've got 15 minus y equals 16. I can subtract 15 to the other side and divide everything by negative 1. So my solution as an ordered pair is 3, negative 1. That's my elimination method. Here's another example for you. 4x plus 5y equals 11 and 3x minus 2y equals negative 9. Now in this equation, I'm also going to do elimination. It may not be quite so clear to you as to whether or not we should eliminate the x or the y variable. So it's really your choice what you want to do. I'll show you how to eliminate the x variable this time. So remember, our goal is to combine our like terms together. So when I combine the x's, I want them to have the same coefficient. So the same number in front, the same coefficient, but opposite signs so that they cancel. So what I'm going to do is I'm going to multiply the first equation by positive 3. The second equation by negative 4. Don't forget to distribute completely. So my first equation, the 3 gets distributed to all of my terms to give me 12x plus 15y equals 33. In my second equation, be sure to distribute the negative 4 completely so that we get negative 12x plus 8y equals 36. And now we're going to combine like terms together. As I was hoping for, 12x plus negative 12x is going to cancel out, so my x's are eliminated. 15y plus 8y gives me 23y. And 33 plus 36 gives me 69. So my y value is equal to 3. Again, we're going to take this answer that we just found, y equals 3, pick one of the original equations from the purple, and substitute 3 in for your y value. I'll go with the first equation again. No particular reason. And I'm going to replace my y with the 3 that I just found and continue solving my equation. So I have 4x equals -4 and x is equal to -1. So my solution written as an ordered pair is -1, 3. What I'm going to do now, I'm going to erase all of this. I'm going to show you another way to solve this exact same equation, keeping in mind that we want to still come up with this answer, -1, 3. Some of you may have chosen a different way to do this, and there's actually multiple ways to solve this problem. So I'm going to clear this out. The first way that I just showed you how to do it was to solve, was to eliminate the x variable. This time I'm going to show you how to eliminate the y variable. We're still going to come up with the same answer. So this time I'm trying to eliminate y. So I need to turn the y coefficients, the y variable, I need them to have the same coefficient. So I'm going to multiply the top equation by 2 and the bottom equation by 5 in order to get the same coefficient. Remember, when you do this, whatever you decide to multiply by, that you make sure that you distribute completely. So now I wanted to eliminate the y variable. 10y plus -10y is going to cancel out. And I'm going to end up with 23x is equal to -23. So x equals -1. That's the first part of my ordered pair. And again, you pick which which original equation from the purple you want to substitute into. This time I'll go with the bottom equation. So instead of the x variable, we replace that with a -1. And I end up with y equal to +3. So I still get the same answer, -1 and +3 as my solution. You may have even chosen other ways to go about solving this system. As long as you get the ordered pair -1, +3 at the end, then you've done it correctly. So also in this section, we're going to look at a second method for solving a system of equations algebraically, and that is called our substitution method. So this is just an alternative method besides elimination that you can use to solve a system of equations. So our first example, we've got 2x plus y equals 4 and 3x plus 2y equals 7. Now the trick with the substitution method is we're going to take one equation and substitute it into the other. So you got to pick an equation to start off with, and the best thing to do is when you look at your two equations, when you compare the two, try and pick the equation in which there is a variable without a coefficient in front. So we've got this y variable in my first equation without a coefficient, so I'm going to use this as my starting equation. And what I'm going to do is I'm going to get the y variable by itself, because it doesn't have a coefficient in front of it. So I've now just rearranged the terms in the first equation to say y equals 4x plus 4. Okay. Now that I've used this first equation, I'm going to go to my second equation. And I have just solved y for -2x plus 4. So I'm going to substitute -2x plus 4 in for my y variable. So it's going to go into this second equation right here. So now instead of 3x plus 2y, I'll have 3x plus 2, and in parentheses, y is now equal to -2x plus 4. So now you'll notice I have the same variables in the equation. So now I can solve for x. So what I'm going to do is I'm going to distribute that 2 to my parentheses. and combine like terms together. And when I get the x by itself, I get negative x is equal to negative 1, or x is equal to positive 1. The next part of this is to find the y variable, because we want to have an ordered pair as our solution, just like before. So we're just going to take this 1, x equals 1, and pick one of your original equations that I have here in the black. It doesn't matter which one. I'll go with the first one. And instead of 2x, I replace my x with 1, and I end up with y equal to 2. And so my solution, my ordered pair, is 1, 2. Here's one more example for you. Using the substitution method, we've got the equation x minus y equals 5 and 3x plus 2y equals 20. So remember, we want to pick the equation that has at least one variable without a coefficient. So that's going to be my first equation. Now we want to think of this y as having a coefficient of negative 1. So that means that I'm going to try and get the x by itself. So in order to get x by itself, I need to add y to the other side. So my first equation has now been rewritten into x equals y plus 5. Y plus 5 is going to be substituted or replaced for my x variable in the second equation. So my second equation, instead of saying 3 times x, it says 3 times parentheses y plus 5. And now we have the same variable in our equation. So we're going to solve by distributing the 3 to my parentheses, combining like terms together, and we end up with y equals 1. Make sure you find the x value for your ordered pair. I'm going to go back to my first equation and substitute in y equals 1, and I end up with a value of x equals 6, and so my solution is the ordered pair 6, 1. Thanks for watching.